This is lecture 6A for Calculus 2 on the area between curves when the integration is carried out with respect to y instead of x. Some curves are written as functions of y and some are easy to consider as functions of y, and of course you can rewrite functions this way at times. But the idea here is that you will have function of y and you want to take the area, and we're going to do the area enclosed so we can practice two things here. So let's say the function with respect to y is y squared minus 3, and then we have another function with respect to y which is negative y squared plus 3. What these are sideways parabolas. And we want to find the area enclosed between these sideways parabolas. So again, as in the second example given in the lecture on areas between curves with two examples, in this case, because we want the area enclosed between the two curves, the limits of integration aren't specified. We have to find them. And here's what we're talking about. We have these two sideways parabolas. Here's one of them, and here's the other, and we want the area enclosed between them. Right. And what we're going to do, this is really the y-axis here. I've written it over here, but we'll put it here. Okay. What we're going to do is find first, this axis should have hit there. Okay, we're going to find these 2 points where the curves intersect, and then we're going to integrate. This will be y1 and this is y2. And now, just as when we were looking at the x, integrating with respect to x, we had to find where f was greater than g and regions where f is less than g. Here it's not greater than or less than, it's right versus left. We aren't going to have that problem here because this parabola is always opening to the left, and this one's opening to the right, and they don't cross. So to find the limits of integration when the problem is stated, area enclosed between two curves, we set f equal to g, and then we solve, and we get y1 and y2. In this case, y1 is negative root 3, and y2 would be positive root 3. Those become our limits of integration, and then we just integrate f minus g. In this case, we don't have any absolute value signs because f is always to the right of g. So when we integrate, we'll get a positive area. Okay, so basically what this lecture, very short lecture, shows is that you can integrate with respect to y as well as integrating with respect to x. Everything is the same as before. You're going to look for the absolute value of f minus g, right? But if it's the area enclosed, you will not know the limits of integration. Instead, you set f equal to g, and from that, you find the limits of integration.